Welcome to the AI for Technical Writers podcast. This is episode 103. I'm Fred.
And I'm Daphne. Hello, everyone, and welcome.
So today we're getting into something a bit counterintuitive, maybe. It's this feeling, this perception that AI progress might be slowing down.
Right, you hear that chatter sometimes, like, have we hit a plateau?
Exactly. But then you look at the underlying trends, and it seems like things are actually speeding up a lot. Exponentially, even.
It's a really important distinction for anyone trying to figure out how to use these AI tools, especially in technical writing and IT workflows. You need to know what trajectory you're actually on.
Yeah, and this whole line of thinking was actually suggested by our producer, senior technical writer, Curt Robbins. He pointed us towards some fascinating research.
That's right. We're drawing heavily from an article titled Why We're Blind to the Real Speed of AI, which was authored by Amy Daali, PhD. It was published back on October 8th, 2025.
Okay, so our goal here is pretty clear. We want to unpack these mental blind spots, the psychological reasons why we might be misjudging AI speed.
And crucially for you listening, we want to redefine maybe what metrics you should really be paying attention to when you're evaluating these models for, serious automation tasks.
Let's start with that feeling of a slowdown. Where does it come from? Some people genuinely feel the AI bubble is deflating, or that we've sort of hit peak LLM performance?
Well, that feeling is often, ironically, a classic symptom of exponential growth itself. It's because the early part of an exponential curve looks almost flat. It's deceiving.
The calm before the storm, kind of?
Pretty much. Dr. Daali brings up the old chessboard and rice problem. You remember that one?
Vaguely. 1 grain on the first square, 2 on the second, 4 on the third, doubling each time.
Exactly. And for the first, say, 30 squares or so, the amount of rice seems totally manageable. A few grains, then a handful, maybe a bag. It feels linear almost.
Right. Your brain can sort of track it easily.
But then you get past the halfway point on the board, maybe square 40, 45, and the doubling just goes nuts. It becomes explosive. Suddenly you're talking about mountains of rice, then more rice than exists on the planet.
And our intuition just breaks down at that point. We can't grasp the scale of the acceleration.
Precisely. So we look back at those early, slower feeling steps and project that rate forward linearly. This is what's known as the exponential growth bias.
Okay, so it's a documented cognitive bias. We're kind of hardwired to miss this.
It seems so. It was first really documented back in the 1970s, and it pops up everywhere. Think about understanding compound interest or debt. People often underestimate how quickly those grow.
Or predicting how fast a disease might spread in a pandemic.
Yes, exactly.
Yeah.
Public health forecasting relies heavily on understanding exponential growth. And Ray Kurzweil famously talked about our intuitive linear view getting in the way of accurate technology forecasting. We see the present rate and just draw a straight line into the future.
Which, for technical writers, planning maybe documentation cycles or tool adoption, that could leave you seriously unprepared.
Yeah.
If you budget based on today's AI speed, and it doubles twice before your project ends.
You're caught flat-footed. Your assumptions about what's possible or what tools to use could be completely wrong very quickly.
Okay, so that explains the general bias,
Yeah.
but let's be fair. There is some anecdotal evidence that feels like a slowdown, isn't there? Specifically around accuracy gains.
Yes, and that's the second major point, the accuracy plateau. We have to acknowledge that.
I mean, the jump from GPT 3.5 to GPT-4, that felt huge, like qualitatively different. But maybe GPT-4o to whatever comes next, maybe doesn't feel quite as dramatic and just like answering general questions.
That's a fair observation. And in many standard benchmarks, the accuracy gains are slowing down. The percentage point increases aren't as massive as they were.
Why is that happening?
Well, largely because the models are hitting the ceiling on those benchmarks. They're approaching or even exceeding average human performance levels, which on many tests sit somewhere between, say, 85% and 95% accuracy. There's just not that much room left to improve on those specific metrics.
Can you give us some numbers? What did that big 3.5 to 4 leap look like?
Oh, it was stark. Let's take GSM-8K. That's a benchmark for complex math and reasoning. Important for things like checking logical consistency in docs, maybe.
Sure.
That jumped from 57% accuracy for GPT 3.5 up to 92% for GPT 4. Massive.
Wow.
Or reading comprehension, like the MMLU benchmark, that went from 70% to 86%.
Still a big jump?
And basic coding, human evil, from
Right.
48% to 67%. These were jumps that genuinely changed what you could do with the models day to day.
Right. So what about the more recent jumps, say GPT-4o to preliminary numbers for maybe a GPT-5?
Well, in those more general reasoning tasks, the gains are smaller. Maybe in a tough reading benchmark like GPQA Diamond, it's like 70% improving to 87%. Still better, definitely. But it doesn't have that same jaw-dropping feel because you're already quite high.
So the curve is flattening on those metrics.
So on those specific metrics, yes. But for our audience, there's one area where the leap seems to be enormous, even now.
Okay, which is?
Coding. Specifically, SWE Bench verified performance. This isn't just generating simple code snippets.
Right, what does it test?
It tests the AI's ability to actually understand and fix real bugs found in GitHub repositories. Verifiable fixes to complex problems. It needs deep context.
Man, jump there.
The reported preliminary numbers suggest a leap from around 31% success rate to something like 75%.
Okay, from 31 to 75% on fixing real-world code issues.
Yeah.
Okay, that's not a plateau at all. That sounds like a massive increase in practical capability in doing actual work.
It completely changes the game for anyone using AI for code examples and documentation, for generating SDK guides, for automating testing, or even tackling technical debt. It's a step towards, well, autonomy.
And that brings us right back to the core question the author Dr. Daali raises, doesn't it? If these traditional accuracy benchmarks are getting maxed out, are they even the right thing to measure anymore?
Exactly. Are we focusing on the wrong indicator, especially if the real progress is happening somewhere else?
So maybe the feeling of a slowdown comes from looking at old metrics, while the real action, the important shift, is happening in a different dimension entirely, like how long the AI can actually work effectively on its own. Let's take a brief break for a special message from our producer, Curt Robbins.
Hi, this is Curt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Technical Writers podcast.
Okay, so before the break, we landed on this idea that maybe raw accuracy on benchmarks isn't telling the full story anymore.
Right. Because getting one answer right in a test is different from, say, asking an AI to draft an entire user manual update. That requires staying on track, maintaining consistency.
Adapting if requirements change slightly, not hallucinating halfway through. It's about sustained performance over time and complexity. That's closer to what we think of as actual intelligence, isn't it? Not just a single score.
Yeah. It's about resilience. How long can it keep going, doing the job properly, before it needs me to step in and fix something or give it a whole new prompt?
Precisely. And this is where the conversation is shifting towards a new key metric. AI. Autonomy.
Autonomy. Okay. How do we define that?
It's basically a measure of how long and how complex a task an AI model can handle independently, maintaining a high level of performance without needing human intervention.
So it directly measures the AI's ability to actually take work off your plate, right?
Exactly. It's the metric that truly matters if you're thinking about automating significant parts of your documentation workflow or other complex IT processes.
And there's a research group actually trying to measure this.
Yes, a nonprofit called METR. It stands for Model Evaluation and Threat Research. They've been focused on quantifying this exact capability.
And how do they measure it?
They proposed a metric called the 50% task completion time horizon.
Okay, break that down.
It essentially tries to find the maximum duration or complexity of a task that a given AI model can successfully complete correctly at least half the time without any human help during the process.
So if a model can reliably handle tasks that take up to, say, 30 minutes on its own, its time horizon might be around 30 minutes.
Roughly, yes. It's a way to put a number on how much sustained, independent work you can expect from the model.
What did MBTR find when they tracked this metric over time? This is where the exponential part comes back in, I assume?
This is where it hits hard. According to their research, this autonomy capability hasn't been inching forward linearly. It's been growing exponentially over the last 6 years or so.
Exponentially? What's the rate?
The estimated doubling time is roughly every 7 months.
Every 7 months. The time it takes for an AI to handle a task of a certain complexity doubles.
That's the finding. And that's why the perception of a slowdown based on accuracy scores is so misleading. You're looking at one flattening curve, while this other, arguably more important curve for practical automation is shooting upwards exponentially.
Okay, let's walk through that timeline. This 7-month doubling changes everything. Where were we, say, back in 2019?
With models like GPT-2, the autonomy was basically negligible. METR suggests they couldn't reliably handle tasks longer than about 1 minute. They needed constant hand-holding.
Right, you prompted them for a sentence or two, basically.
Then jump to 2023. Models like GPT-4, Claude 3 Opus, the autonomy horizon stretched into the 5 to 30-minute range.
Okay, that's enough to draft a short section, maybe summarize something, generate some basic code examples. Useful, but you're still checking in frequently.
Correct. Now, fast forward to late 2024, early 2025. The leading models, maybe like Claude 3.5 Sonnet or hypothetical next-gen ones, are pushing towards maybe 30 minutes to nearly an hour of reliable independent work.
An hour? That's starting to be a significant chunk of delegated work. You could potentially ask it to complete a more substantial subtask.
It's getting there. But now, apply that 7-month doubling rate going forward. This is where the projections get really interesting for technical writers and IT teams.
Okay, so if we're at roughly an hour now,
Yeah.
7 months from now, mid-2026 maybe?
The projection suggests we could be looking at systems capable of around 6 hours of autonomous work.
6 hours? That's
What?
most of a working day.
Think about it. You could potentially task an AI agent at the beginning of the day,
Yeah.
review these API changes, update the corresponding documentation sections across these 3 guides, generate new code examples, ensure consistency, and flag any potential conflicts for human review. And it could potentially handle that whole workflow autonomously for 6 hours.
Yeah. Okay, and then another 7 months, late 2026.
The projection hits approximately 12 hours of autonomy, a full day-night cycle's worth of potential work.
And beyond that, where does the curve take us in, say, 2027, 2028?
If the trend holds, by 2027, 2028, we could be seeing systems capable of handling tasks that require 1 to 2 full days of continuous autonomous operation.
Days of autonomous work.
And looking even further out, say late 2028 to maybe 2031, the projection, if the exponential trend continues, points towards AI systems potentially capable of handling projects autonomously for a month or longer.
A month? That's not just an assistant anymore. That's an autonomous agent managing significant long-term projects. Maintaining entire documentation sets, perhaps.
Potentially. It's a profound shift in capability, and it highlights why focusing only on static accuracy scores misses this huge wave of increasing autonomy.
So the author's conclusion is that this exponential growth in autonomy is the real story, and it might continue for a bit longer even with current tech.
Right. Dr. Daali suggests that the current large language model architectures might be able to sustain this kind of exponential autonomy growth through 2026, maybe into 2027.
But to keep that curve going steeply upwards beyond that.
We'll likely need new breakthroughs, new architectures. Things like world models, which have a deeper, more causal understanding of how things work, or other forms of more embodied AI that can interact and learn more dynamically.
It really reframes how you need to think about preparing for the future of AI in technical communication. It's less about, is the AI slightly more accurate, and more about, how much sustained, complex work can I reliably delegate to it?
Absolutely. And that exponential increase in autonomy brings up a really interesting challenge for you, the listener, to think about.
Which is?
If AI systems start handling complex documentation tasks autonomously for hours or even days, what does that mean for our standards of review and auditing? How do you ensure quality, consistency, and factual accuracy when an AI might have been iterating on a set of interconnected documents for a whole week without direct human oversight on every step?
Yeah, that's a huge question. Checking a paragraph is one thing. Auditing the output of a week-long autonomous project that requires entirely different processes and skills.
It's a shift from micro-level editing to macro-level validation and system oversight. That's perhaps the next big adaptation required, driven by this accelerating wave of AI autonomy, something to definitely keep an eye on.
Thank you for listening to the AI for Technical Writers podcast, where we help you get smarter than your competition. Remember to like, subscribe, comment, and share. We'll see you next week.